At the core of calculus lies the concept of limit, a fundamental idea that underpins the entire framework of this fascinating discipline. To pave the way for our exploration of the concept of limit, allow me to begin our journey with a story about investment. Meet Ben, a thrifty individual seeking to invest his hard-earned 100,000 pesos in a bank for 1 year. His goal is to maximize his returns, so he decides to explore the various options available to him. Ben sets off on his journey by visiting the first bank located on the first street. The approachable and kind manager offered Ben a cup of coffee. While he discussed the bank's deposit scheme, the manager explains that the banks offer a straightforward annual simple interest rate of 10%. This means that Ben's 100,000 pesos will grow to 110,000 pesos at the end of the year. Although this gain may seem modest, Ben remains hopeful and continues his quest. He proceeds to the second bank situated at the second street. Greeted by yet another approachable and kind manager, Ben is once again offered a cup of coffee. The manager reveals that their bank also offers 10% interest rate, but with a twist. It is computed twice a year using compound interest. Basically, the 10% rate is split into two parts. The first 5% will take effect in the first half of the year, and the resulting amount will then be subjected to the remaining 5% for the next period. In total, Ben's money will grow to 110,250 pesos, a better offer compared to the first bank, right? But Ben, not content with just this option, proceed to the third street where the approachable and kind manager in the third bank is waiting. He was invited inside the bank and served with, guess what? A cup of coffee. As expected, a 10% interest rate is offered. However, there's an additional perk. Ben's money will grow every 4 months. The manager explains that the 10% rate is divided into three, with each portion taking effect in different trimestral periods. Therefore, at the end of the year, Ben can expect a total amount of 110,330 pesos or 110,337 pesos. An even more enticing offer than those from the first two banks, right? Still yearning for a more enticing deal, Ben embarked on his journey to the fourth bank. He anticipated yet another cup of delicious coffee and possibly a more attractive offer. And true enough, the fourth bank proposed a 10% interest rate compounded quarterly. And the computation unfolded as predicted. giving Ben the amount of 110,381 pesos after 1 year, alongside with the satisfaction of savoring a delectable cup of coffee. Yet, Ben's quest did not end there. Driven by the allure of continuous improvement, he visited few more banks. But later on, fatigue set in, compelling him to call it a day. As he rested, and because he could not sleep due to the volume of coffee he drank, he could not help but wonder, contemplating the possibilities for his money based on the various offers he received. He had few observations. One, he realized that the potential for his money to grow seemed to be continuous as he explored more banks. However, he also figured that the amount of increase is not getting any better. So he formed this hypothetical question in his mind. If an infinite number of banks existed, would he amass 1 million pesos within a year by depositing his money into the bank located at the Infinity Street? In tackling such intriguing question, we need a tool that dwell on not just on a finite process but also on infinite process. This is because algebra does not know infinity. The available tool that could dwell on infinite process is therefore not algebra, and this is where calculus comes in, the whisperer of infinity. This is an exciting journey, and I hope you will join me as we uncover the fascinating world of calculus. We begin the lecture proper by laying the foundation of calculus, the limit. Then we proceed to derivatives and then integrals. So what is a limit of a function all about? The question that Ben asked in the previous scenario is very much connected to the concept of limit. The amount that he will end up receiving after 1 year when his money is deposited at an interest rate that compounded n times a year can be modeled by the function f of n equals 110,000 times quantity 1 plus 10% over n raised to n. Here our concern is to identify the resulting value of f of n when n is forced to grow without bound. Roughly speaking, the concept of limit is just about that. For a function dependent on the variable x, the concept of limit is concerned with the behavior of the function as the independent variable x approaches a certain value, or even beyond towards infinity. Before we discuss the mathematical definition of a limit of a function, it would prove useful to get an idea or insight of what it is. Through informal definition, we say that the function f has a limit L at C if f of x can be made as close as desired to L by making x close enough to C. This situation can be expressed using this symbol. This is read as the limit of f of x as x approaches c equals L, or simply the limit of f at c is L. The formal definition of limit will come after the discussion of numerical and graphical approaches. That will be the next topic after this video. And we will talk about limit as well as we will answer the problem that Ben had, or his question about the money that he will end up with after 1 year when he deposit his money into the bank located at Infinity Street. What we've just discussed is just a taste of what it is to come. But at least you get an idea of what limit of a function is about. So the topics that we will cover under limit are as follows. We start with finding a limit of a function through different approaches. As I said, numerical and graphical approaches. These are intuitive approaches. And then we also talk about the very definition of limit. In this case, we will introduce the formal definition. Um, that is where we will um, depart from the intuitive approach. Next, we will discuss cases when limit does not exist. Then the difference between the limit at C and evaluation at C. There are many students who find it confusing, so we spend some time discussing this part. Next, the properties of limit and the techniques in solving limit. We will also cover the concept of continuity of a function, as well as the infinite limit and limit at infinity.
Awesome!